Okay, let us get started into this session. So this session focus is on modules and packages, and then also we'll look at how do we debug in a nice way. That means in a professional way, how things happen in industry, or in any nice package that you download from online. Okay. So, coming to modules and packages. So let us take an example that we are trying to do already. So let us take that example as COVID-19, and we are trying to extract some statistics. And if we have to write a project on top of this, say I have a requirement that okay, this COVID project, the requirements, simple requirements are okay. There should be a dashboard whenever I enter into that particular website that I'm going to develop. So it should display me a dashboard telling that okay, this many states are affected, and if the mortality rate is more than 1%, put me in red zone or yellow zone or things like that. So various kind of statistics and um, its severities. Okay, so that is dashboard. And then maybe we'll also create a module or a subsection of a project. So another requirement is that anyone should be able to download a report in form of say HTML or XML or JSON, or even in an Excel sheet. So that is a second requirement, downloading the report. And then first requirement was a dashboard. And then let us also think that we have a automated test suite in for to make sure that this project is working fine. So what we write is we write unit test cases or regression tests, which automatically tests the entire functionality. Okay, so these are the modules that we kind of split it into a few modules. And then let us try to create directories, just to handle those files in a particular subset. Okay, so these are the probable packages, or these are the probable modules that I can create. So let us just for simplicity, let us just think of it as a folder. So reports is a folder, API is a folder, test is a folder, and then there is a file which starts all of these processes. Maybe it brings up it connects to a database, and then it connects to a internal server or something like that. So that is a starting point of this project. So once this is up and running, then let us think that there is a we have a web interface, and you can see the dashboard, and also there is a way to download the reports. And maybe we have another package called as API. Maybe we expose some APIs to other modules, or other people who can just make use of that and try to do something out of that. So these are the modules. So then let us try to fill in some modules, or let's try to write some files into that. So those files can be like this. So these are imaginary. So reports, maybe it has it has two files, dashboard.py and excel.py. Dashboard, this takes care of putting things on dashboard and displaying stuff. And this takes care of maybe generating Excel sheet um, from a database, or from something we process. That is about this file. And then maybe there is a file called api.py. This will take care of this has all the functions and logic, which will expose the API, and others can make use of it. So this is a test folder. Inside that, maybe I have a file called auto tests. It actually calls maybe all the functionality of it tests all the functionality of these three modules or files. Okay, so that is how maybe we can organize our COVID statistics project into a small Once you look at the folders, you should be making out anyone who is looking at the folder, any developer looking at the folder, he should be making out that okay, reports. This folder contains something related to reports, and this API. Okay, this contains something related to API, and this is a test folder. Okay, this is a test folder. So it is obvious when you start writing code in a neat in a divided manner. So this is how we kind of specifically tell that okay, this is how code is organized. If you imagine, if you put all these files in one place, what happens is, suppose we have multiple files here, and files could be file names could be repeated, and it is also possible that the file names are ambiguous, and they don't make any sense sometimes. So maybe those files are used only for internal purposes and all these things. So such problems are eliminated when we try to divide things into different organizing modules. So from the software perspective, its modules are just each part takes care of its own. It has a responsibility, and it does only that responsibility. So packages are nothing but this whole thing we can call as a package. This whole project we can call as a package, and also we can call this as these three things as sub packages, and maybe this can be called as modules. Okay, so generally let us get used to term called modules as files. That means .py files. That doesn't mean that any file that you see is only those are called modules. It just means that files are modules, and it is also possible that a folder can be called a module in certain context. But for simplicity, we will just stick to modules means .py files. Okay, so then we will get used to as and when we try to develop a mini project, then we get used to what is package and what is sub package and what is modules. So just for our simplicity, we'll consider py files as modules. Okay, so that is about packages and modules. Let us try to write some code and look in the interpreter or in the code. Okay, so what I was trying to do was just click it. Okay, so what I'm trying to do is I have created a folder called COVID. Okay, inside this, so that is a project folder, and then let us try to see let us try to import that. Okay, so Python, I am going to open an interpreter. Okay, so COVID folder is here. Okay, so when we try to import something, what happens is Python tries to compile that code and try to make bytecode out of it. So that bytecode is kept under pycache folder double underscore pycache double underscore. So don't worry about this. Okay, so it gets automatically created. Okay, now we have a folder called COVID, and in case I want to make use of that package or that module, what I do is I try to bring that context into my current context. My current context is interpreter. So what I'm to bring it into my context, what I'm going to do is import that COVID. Okay, so COVID got imported here. That means I can access all the code that is written here, and I can make use of it. So it's an empty folder right now, and there is a file called as init.py double underscore init double underscore .py. Okay, this file, if any folder contains this file, that tells that okay, this folder is a Python package. Okay, so the reason that we do here is it automatically creates, since this is an object, it automatically appends some of the attributes. Let us see what are those attributes um, that can be see it has added all these attributes automatically. Okay, so let us take one of them and check COVID. That is an object. So when we import something, it becomes it comes as an object for us. So let us try to see what is package. So the package name is COVID. Let us see what is path. So that means, okay, this package is located here. Okay, say for example, if I have uh, somewhere in the folder structure, if I have um, two folders which are called COVID, so then how do we import it? So we can also use aliases, something like import COVID as um, old COVID. So we are just creating a name. It is as good as saying something like a is equal to b. Okay. So I can use COVID instead of COVID. I can use old COVID uh, uh, as a new name. Okay. So that is one of the concepts. Like you can change its name in the current context. So to bring it into the current context, you just use import. Okay, that is about very simple idea about packages. So it can contain subfolders, and then it can, as we saw in the slide, maybe it can contain subfolders, and each subfolder can contain init file. This is called as init file. So the reason for having an init file is because it we can also write some code whenever the package is imported, or whenever it's executed from. So we can initialize some stuff. Maybe we are initializing some log files, maybe we are initializing some temporary file names that we are going to create, or maybe we are initializing some sorts of settings. So such things can be done in it. So it can be also an empty file. So if there is a just remember that if there is an init file in the directory, that means that is a Python package. Okay, so in Python 3 dot after 3.3 there are two kinds of packages. Let us not get into other kind, because it's a little bit confusing to get both of this. So this is a traditional package. So there is also called as something called as namespace packages. So that you can study about that on the documentation section. But let us stick to this package. This is a package. How do we recognize a package? If it has init.py, that means it is importable, and I can import the modules, and I can look at the modules, and also it gives some ready-made attributes. Okay. So that is about the package. And about modules are just nothing but files in the current context. Let us try to move this into this folder, COVID folder. Okay. Or sure, yes, I want sure. Okay, this now I have moved this file into this folder. Let us look at this. Okay, so we have a folder here, and we have a file here. We just move. Okay, now let us get out of interpreter and again come back. Okay, so let us again import it, and let us look at what are the contents of it, that is attributes and functionalities. Okay, so COVID has again this stuff, and let us try to access COVID dot import COVID dot COVID state wise stats. Okay. Okay. I need to import from COVID, import COVID, dot f is equal to, I will be imported specifically COVID state wise underscore stats. So as you saw, as soon as we import it, Python just reads through it and tries to generate a bytecode. That means it actually executes the whole code once. So okay, now we have COVID. We have imported the module from COVID package. Okay, so that is how that is about modules. Okay, so now this module I can use this module to if I have functions. Modules are nothing but it has some functions and some statements. Okay, so if I have the whole thing in a function, um, I can use something like, okay, COVID statewise underscore stats dot that module. So that function. Okay, so files are modules, and we can have as many files and we can have as many directories. So those can be called as sub packages. So that is how we organize a package, or a software program that we need to handle it correctly. Okay, so that is about modules and packages. So actually this is a this has much more deeper things into that. So you can read that on Python documentation. But instead of reading that, what we do is we can just start writing programs, and as and when we kind of hit into a wall, then look up the documentation and it gets clear. So in order to understand those documents, just this is required. Okay, so this is package, and there are some files which indicate that's a package, and this is a module. So that is how it is organized. So that is about very brief introduction about packages and modules. Okay, any questions? Okay, so let us move into, okay, anyways, when we start doing mini project or a problem statement, and then it will be clear, and you will anyways have to face all the problems that when we are trying to import a package, and there will be issues like that module is not found, how to search, where to search, and stuff like that. Okay, so that was about packages and modules. So let us look at debugging. Okay, so little bit about debugging. So why do we need to debug? Because in order to find out find out the bugs, or while making writing freshly, we need to know the program flow, and we need to kind of make sure that my logic is working as expected. So in order to see those flows and visualize those flows, we need debugging. So how do we debug generally? If you're writing a small program, just and you're doing some prototype, you just write a script in a Python file, and we are just printing some values. Like if you want to see values inside the dictionary, you just print it. Okay. So we are using print statements in order to debug the problem. In fact, okay. So we're already doing this. So the problem with print statements is that imagine you have a website which is running on Python, and there is some problem. So this program or Python program won't be run using on a shell um, or on a visible shell. That means it will be in a background. So you cannot um, log into say on a screen and see all the print statements, because print will be printed only on the console. So all the things such as embedded systems and all the websites that are running there, they are running without any consoles. So that means they are running in a background process of in a system. So print only handles or prints on the console, that is on the monitor. So how do we preserve, or how do we make sure that our statements or our print statements or whatever I want to print, it is stored persistently? For that purpose, we what we can do is, we can, instead of writing it into a monitor, we can write it into a file. So instead of directly writing it into a file, that means you can open a file and then you can open it in append mode and start writing your print statements or your statements, and then just dump into that file, okay, instead of print statements. So that is one way. So the problem with the file is, so there are several problems when you open your own file. So one of the problems could be like your program is running in a multi-threaded or multi-process uh, way. So a file can be accessed by multiple threads or multiple processes, and maybe one process is writing into that particular log file, and then another process is also writing into that log file. So then you get then there is a conflict, and maybe you get some kind of junk values, and or maybe the text is merged and you cannot make anything out of it. So that is one of the problems. And maybe you need to add some features, such as, okay, when is this statement happening? Maybe you need to you kind of want to print a date and timestamp, so that in future you can look at that timestamp and say, okay, at this timestamp this was happening, so I can look at that log files. Maybe you want to print function names, maybe you want to print file names. So all these kind of features that you might be thinking, it's difficult to embed into your own function. Okay, so all this logging system is a recurring process. That means every software has a logging process. So such things are usually made as a libraries or given as a packages. So logging is one of the modules that Python comes with. So in the module name itself is called as logging. So we can import it, and we can simply use it without any worries. It can handle all the problems that you can foresee. So while logging, so there are different levels of logging, such as critical error, warning, info, and debug. So the reason for levels is that you can enable this say when you deploy a software onto the customer location, you have too many logs. For example, developers, if they want to print statements inside a for loop, say, so if that for loop is doing so at development level, maybe we are inputting maybe 5 or 6 input values into that for loop, and I get maybe 5 or 6 logging statements. But imagine when we deploy that into customer location, maybe we are getting more than 1 million entries, and all of them are printed into the log file. So log file grows, and it may grow into MBs and GBs, and then it's difficult to handle, or it is consuming unnecessary space. Okay, so in such cases what we do is we can put that particular log as info log, instead of removing the whole thing. So yeah, put it as info log, and then maybe we can, in the settings, when we are deploying the project, we make a setting in logging settings, telling that okay, do not print, ignore info logs. So such things can be controlled at the settings level. So that is why we and maybe if there are too many debugging logs, there is a level called debug. So debug can be used only if some problem occurs. So if you suspect, say if you are trying to open a file and that file doesn't exist, so in an exception you handle that, and so soon after handling, you just put a logging statement telling that okay, this is a debug log, and this error has occurred. Okay, so that you can look at that problem later. Okay, so that is about debug and info. And some things could be like very critical, such as say we are now in our imaginary project dashboard. Nothing is getting printed on dashboard, which means our purpose of having a dashboard itself is um, is is um, uh, is invalid. So such that is a critical thing for me, because that is the service that I'm providing. The service is itself not served. So that is a critical problem for me. So maybe if I'm using say a certain data structure, say if I'm using a map or dictionary to make use of that dashboard, that means I'm printing the dashboard using a dictionary. So if dictionary is empty, then I'll just print a critical log saying that okay, dashboard is empty. Okay, so that is why we use various levels: critical and errors. These are not these are just for our conventions. So these are just you can use errors for everything, you can use critical for everything, you can use info for everything, but we need to use it in certain way, that we always must think that this log and the code is always read by several people, not only just one person. So that is the idea about having different levels, and then to avoid unnecessary printing. And also we can just simply we have five different levels, or 5 or 6 levels of enabling logs. That means maybe I'm if I'm interested only in critical logs, I can simply enable that and print those critical logs. Maybe I need only critical and error logs, I can do that. So there are a lot of stuff that you can do with the logging module. So that is how in software industry, maybe you have already seen a lot of logs having saying that okay, this is warning log, this is a critical log, this is an error log, and stuff like that. Okay, so that is about how we debug in already deployed software. Okay, so that is about logging, one way of debugging. So there is also another way of debugging, which is like for example, the what happens is, um, uh, if if you are when you are developing, it is possible that some of the logic could be slightly complicated, and maybe you're reading someone's code, or maybe you're not understanding, maybe you want to put some input, and then you want to figure out how this logic is working. So in such cases, what we can do is we can use something called as sorry, it's not the GDB, it's PDB. GDB is actually coming from C and C++. GDB is called as its full form is GNU debugger, so that is why it's GDB. And similar terminology is used in Python, so it's called PDB. So it's not GDB here, it's PDB. So Python debugger. So the idea in PDB or GDB is you can also put breakpoints at a code or at a function level or at a certain line number, and then you can halt the program while it is running, and then you can try to print those values. Okay, print those values, see those values. You can also assign those values and do a bunch of stuff. So let us look at logging and GDB, because we have already covered prints during our normal coding. Okay, so how do we import logging? Just import logging. Logging is a module. So actually there is a configuration that you can make the. So actually you can put this in a configuration file, and then you can read that configuration file here. But for our simplicity, what we are doing is we are just uh, putting it as a debug level. In case if you do not have this, it takes by default settings, and let us try to just run through this. Okay, so what I'm going to do is I'm going to quit this interpreter, and let us try to put some logs. Okay, in the try block I have so I'm going to remove all the prints for our because now we are growing up. uh, Print is a very crude way of doing things. Okay, so let us try to put. So this is an exception. So exception, whenever there's an exception, so I decide that I can put a debug log, but for me it's an error, so I can use error, and similar to printf I can just write file not found debug y. Okay, and then for JSON I'm going to print something like structure. It's not right. Check. Something like that. Okay, so I'm just going to remove this because I'm not going to use that. Okay, so I'm going to remove print. I'm going to, instead of removing, I'll just if key is active. So let us try to put a log here. So this is not an error log, so I may be deciding to put it as a, say, info log, because I'm trying to use that as at a developer level. I'm just trying to check some values, so it is just for information. Okay, so at info level, so what is this? State, and percentages is that tells that, okay, at this place insert this variable. Okay, so this idea is coming from C++. Okay. Percentages means it will print this, and it's a variable. So let us try to run this program. Where is this program? Okay, it is inside COVID, Python COVID, and then COVID starts. Okay, so let us see. What's happening? Let us look at the folder. Where is my file? Okay, let me just define the file. configuration, have I imported it? Yes. Okay, so where is my log file? Okay, initialize log file. Let me quickly search that. Python logging init log file. Okay, that is how we find out things. Where is the log file nationalization? Okay. Okay, I'll just take this and modify it for my purpose. Okay, so let me use that login configuration and run it again. Okay, file got created. Cool. Okay, but nothing is printed. What am I doing? I'm doing KB. Where am I writing it? File mode, basic configuration. This will get locked. Where is the why is it not printing? Do I need okay? Okay, I think I need to initialize okay, this is info logs. Debug level have I initialized? Initialize debug logs. Give me a minute. Okay, I will initialize this level. Okay, good. Okay, we had not initialized the levels, so by default it's not getting anything. Okay, so now we have, okay, I was trying to trying to get info logs, and to get this we need to enable this. Okay, so this is a module and there are some settings, and then we have enabled that settings. That means, okay, we're telling the logging module that enable info logs. So now after enabling, we have got those logs. So this is how you try to make use of logging, and let us try to get this as printed as well. So that file is not there. Let us look at the file. Okay, now we have got an error log. That is because this file is not present. Okay, so that is how you handle errors. Okay, in a nice neat way. So this thing, so we are running on terminal. So that means if I print statement, if I have a print statement, it will obviously get printed here. It is possible that this is running as a cron job. That means it is running in a Linux cron job in the background, and maybe some other process has initiated this process. So in such cases, print statements won't work. So that is why you require logging. So once this logging is there, you can always go back to this log files and check what is happening. Okay, so that is the idea about logging. Okay, now let us look at GDB. Any questions in logging? So it's just a module and you can write it into file and you have different various levels. Just remember that. And you can do a lot of things. So we just took the settings. Okay. Any questions on logging?
Nothing else.
Okay. Okay. Let us learn a little bit about GDB. Sorry, PDB. I think I need to correct this. PDB. Okay. So coming to PDB. So now we know that we are trying to run this program and it just runs and it is giving it is behaving as we are expecting it. So since this file is not, that is, it's telling that it is printing this error and coming out. Okay. So it is not halting the problem. Now since we have try and exec block, it is not halting the program structure. Say for example, if you want to if your intention is to halt the program and then try to get your hands on onto that particular variable. So for example, I can, let me change the file name back. Okay, I can maybe I want to look at I want to look at maybe not problem. Once JSON is loaded, maybe this part of the program, that is this part of the program is not getting executed. That means it is getting executed, but it's not getting executed as I expect. Maybe state-wise data, this dictionary is empty. So I need to find out why this dictionary is empty. Okay, so in such case, what you can do is either you can put a log, but sometimes your logging, what happens is it's difficult to get logging, read the logs and print all the variables, because there could be a lot of variables and there could be some logic that you want to test in your local system. Okay, so PDB is not used in production setup. It is simply just for our development purpose. So let us try to import. There is a module called as PDB. Import. Okay, PDB. Okay, so this is the module, and then PDB has a function called as pdb.set trace. Okay. This stops the um, execution of the program, and it will give you a terminal like this. Let us do that. Now this is a PDB terminal. Here you can do a lot of things, such as I can, if I press L, that means it will list the current execution code. That is, it is the instruction pointer is at line number 20. So this is where we are. Okay. So we have stopped the execution and we are at this level. So it is telling that we are. So I can now I can also go execution or line by line execution. That means if I either press next or the shortcut is N, so it will execute line by line. That means it we were at 20, so I stepped into two statements. So now we are at 22. So we executed these two, and it is waiting at this statement. It is waiting to be executed. So I can step into statements, and also if there are functions, I can jump inside that function. Okay, so let us see, where are we. We are at for loop, and maybe I want to print this. So okay, so this is how the items are. Then I can look at this information and easily find out what is happening. Okay, since we have static data here, so it's obvious that okay, I can control this and I can debug easily. But if you have a dynamic data, that means there are a lot of JSON which are getting dumped by different processes or coming from different sources, and then you're trying to process it. So then we have a problem. Then we need to kind of stop the execution, and then go line by line and find out what is happening. So there is a lot of things that we can do in PDB. For example, I can set in fact I can set a breakpoint at I think the breakpoint. Before starting the program, I can also set the breakpoint and tell that okay, stop at line number, certain line number. Okay, so that is um, about PDB. So this you can simply use it like this, or also you can on the command line itself you can start the program. So you can that you can study it later, but this is how the PDB works. You have a program, and you need to kind of halt the program. Now it doesn't get halted because it's not, we have removed that statement. Okay, if you want to halt that program and then stop it and look at it line by line, and now you have a lot of time and patience to look inside that. So we don't usually use PDB in a customer setup, because also while checking in your code, or when you're sending your code to customer space location, we remove all this kind of statements, PDB and print statements, because one is because we don't need print statements, because it's useless, because it won't get printed on the screen. Second thing that we don't use PDB is because PDB will halt the execution at customer location, and it won't execute the next commands unless you go and do something there. You give a continue command. Okay, so that is why we don't use PDB at customer location. PDB is specifically designed to find out things at your location. That means at a development level, and then find out things line by line. So you have a lot of control. That means you can step into a function, you can line by line you can make it executed, and then also you can put some kind of breakpoints, and then jump into those breakpoints, and also you can modify the variables and see if that is working. So these are the uses that PDB provides. It's just like you hold the process and you take the control of that program instead of interpreter doing it. Right. So that is how we debug the program. Okay. So any questions here in debugging? So unless you use it, it's difficult to appreciate it, um, uh, because these are just simple concepts, and it's always nice to know these concepts, because debugging is like day-to-day job. That means you keep doing it always. Okay, so logging is must in your programs, and PDB is at your local location. Okay, so that is about packages and modules. Actually, there are a lot of concepts in packages and modules, such as how do we import, what are the cyclic, what if there are cyclic importing, and how does Python find out where are the packages. It's how does Python path variable look like, and what are the system variables that Python uses. Such things are there in the background. So these are the basic ideas that we can use and learn about packages, and then we can relate to those problems when we hit it. So when you hit a problem, you just know that okay, this is a package and this is a module. So if something is not working, just look up online, and then you can relate to that. So that is the idea about these two concepts. So it's a lot deeper than we learned now. So this is just to give a heads up to this stuff. So with these concepts, we can easily design this particular problem, that is COVID statistics and reports. But if you are using multiple packages, tens of packages, and if you are using a certain framework, and if your process is multi process software, and then there are a lot of variations in software, then you might get into some problems. Then it's easy to solve the problems if you understand this. So that is about packages and modules and debugging. So I'll post some questions and assignments on top of this. But before that, if you have any questions, we can discuss.
So, again, this actually logging or let's say debugging. So we can do it at a like at a high level, right? It can be at a function level or
Right. Yes. Yes.
actually,
Yes.
yeah,
You can do it on any level.
sorry,
Yes, it can be at any level,
it
function
can be
level or
okay. And with respect to this packages, right? So, are there any set of packages that are mandatory while writing a program?
no, no, no,
Like,
no, no, no. It depends on the requirement. There are no mandatory packages, so you can just start writing a program, just like we started writing our own programs in
right,
on the console, right? So we didn't use any package. Uh, so, for example, if you want to build a website, and there are frameworks such as Django, Flask, and stuff like that, so you can download them and then use that. So downloading is simple. There is a command called pip, and then you can search for that module online, and you can download Python packages. It will give you a pip command, and then maybe you can simply download those packages. For example, I can show it here. Pip, say I want XLRD, which does XLS operations, read operations. So sorry, pip install. So this is how you install packages of on from online. So this stuff you can actually look up. That's let us see what it does. Collecting, yeah. I already have pip XLRD installed. Or okay, sorry, no. It is the package is not present. Okay, let me check. So what we do is usually, if you want to, if you have a certain package to handle certain stuff, right? So I can use Python XLRD package install. Okay, if you just search for that, yeah, you'll get the package name in the Python package installation project. So you just copy that command. Oh, it's XLRD. Okay, I think you just
yeah, I think it was even XRLD.
yeah, right, yeah, spelling mistake. Okay. So it just downloads. It's trying to collect. Okay.
Hmm.
Now it says okay. Now you can just to make sure that if it is downloaded or not, you can just just get into interpreter mode, and then you try to import that package. Import XLRD. Yes, yeah, it's successfully installed. Okay, so just XLRD. It will give all the operations that is required for your program. So this is how you install and import it.
Okay, cool. So yeah, again, besides that, right? So can you post those sample programs as well, just for the
Yeah,
reference?
yeah. Yeah. Maybe I was thinking I will put this on GitHub and share the link so that you can
Okay,
just copy that and
sure.
use it. Yeah, I'll do
All
that.
right.